Alright, here we go. You're probably going to get the background noise of the rain coming in through my windows and the thunder, but we're going to do the best that we can here, and hopefully the power doesn't go out. So, Chapter 3 is all about parallel and perpendicular lines and the relationships between those different items. So, parallel lines are going to be lines in the same plane. And that's important that they're in the same plane. That never intersect. It is possible that lines in different planes never intersect, but we wouldn't call those parallel, we'd call them something else. So in this case, something like this would be two parallel lines. To mark on the picture that lines are parallel, we use little arrows instead of like tick marks, and that shows you that those two lines are parallel to each other. Skew lines are going to be lines in different planes that never intersect. And if you think about that, like look around the classroom, lines that would never intersect would be like one of the like the edges of the ceiling, and then the vertical side of the wall on the opposite side of the room. So, for example, if we were to think about like a cube, or even a plane like this, if this was our plane, and I have one line here in my plane, and then I were to have another line maybe that goes vertically through the plane like so, those lines are never ever going to cross because they're going completely opposite directions in different planes, and so that is what makes them different. Parallel planes are exactly what they sound like. I don't really have a good definition for parallel planes, but it would be, two planes that are, it'd be like if, the front wall of the classroom and the back wall of the classroom, those planes will never ever intersect because they're parallel. So it's just like lines except extended to another dimension. So here's an example of sort of identifying some of these things in a diagram. So if we're looking at, it says, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So the first one is we want lines parallel to line CD and containing point A. So here's CD. We want lines that are parallel to that contain point A. So the only one that would be would have to be right here. So what is that? Line AB. Those would be the only ones parallel that contain that point. So now for question B, we want lines skew to CD and containing point A. Well, there's multiple answers for that one. There's actually two. We could have line AH right here because you can see this would be like the ceiling and then the back corner of the room. And then we also have AG right here. Even though it kind of looks like this is pointing towards line CD, you have to remember this is three-dimensional. And so that would really just be off in space somewhere else. It would never get to CD. So that would be lines AH and AG. Perpendicular, we've already worked with some. So lines that are perpendicular to CD and containing point A, again, there's really only one. We can see that that's supposed to make a right angle because it's marked right here. So that would be AD. And planes that are parallel to plane EFG. EFG, that would be this bottom plane here. So the only plane that would be parallel to that that contains A would be, we could say plane ABC. It would be the top of the room up here. Okay. For me, it's the easiest to think about skew as a box. So I think this is kind of a good representation of what that would look like. Okay. Now, the parallel postulate and the perpendicular postulate. The parallel postulate says if there is a line and a point not on that line, then there's exactly one line through point P that is parallel to the given line. There's only going to be one way that you could have drawn that red line through P. Any other way that you would have drawn it, it would be at a slightly different angle, and therefore they would have intersected eventually. The perpendicular postulate says the exact same thing, that there is only one way to draw a line that is perpendicular to that red line. Again, if it were to go at any other angle, it would no longer be 90 degrees, and therefore it would no longer be parallel. So let's look at this next example, and it's really important that we look at the markings that are on the picture. So we're trying to identify things that are parallel and perpendicular. So some important things here to notice is that we have right angle symbols, and we also have parallel symbols. These two arrows here and here show that those lines are parallel. None of the other ones, it looks like, have those kinds of markings. So even though, for example, line, say, FG and line JK look like they're parallel, since they're not marked on the picture, we can't make that assumption. The only ones that we can say for certain are the two that are marked. So the parallel lines would be line GK and line HL. Perpendicular would be the only ones that make that right angle there. So I could say NK and let's see which one is parallel, GM. And there's more than one way that you could name these lines. So then the question is GN perpendicular to JL? And we have to say no, because there's no right angle marked on that picture. I mean, it kind of obviously looks like it's not, but we can go ahead and say that it's not because they haven't marked anything to give us that information. So we can say no, it is not marked on the picture. Okay. It's really sloppy, sorry. So, a little bit more vocabulary here, and then that's pretty much the end of this section. But this is probably one of the most crucial bits of this chapter. We have got to get this vocabulary down because it's going to show up in everything that we do from here on out. And so hopefully you recognize some of these things. So, a transversal is a line. Oh, sorry, there was a mosquito on me. A line that intersects two or more other lines. Two or more other lines. Oops. Okay, so for example, if I had this line, and then I have another line that comes through like this. The red one, which we'll go ahead and call T, is the transversal because it intersects each of the two blue lines. So when we draw a transversal, especially across two lines, we have specific angle pair relationships that we want to be looking for. And so every single one of these next ones is going to be describing some relationship between the angles that are here, that are formed by these, by the transversal. So the first one is corresponding angles. And so corresponding angles are the ones that the easiest way to think about it is that they match. So they're going to share the same location on each line. And I'll show you what I mean by that. So there's going to be two lines crossed by a transversal. So let's look at a sketch of that. Here's two lines. Here's my transversal. Okay. Corresponding, we'd be looking at the top four angles that are made compared to the bottom four angles that are made. So these, if I were to look at this angle, of this 1, 2, 3, 4 here, that's the top right. So if I go to the bottom cluster and also look at the top right, those are corresponding angles. There are 4 pairs of corresponding angles because I could also look at, if I were to say the bottom left, for example, then the bottom left over here would be corresponding. So there's multiple pairs. The other 2 each have a match as well. So alternate interior angles are going to be on the interior of the 2 lines. Whoops, I don't know what I'm writing here. Interior of 2 lines. And they have to be on opposite sides of the transversal. Whoops, opposite sides of the transversal. So, here's my lines, here's my transversal. If I were to mark this one, then its alternate interior angle would be still between the lines, but it would be on the opposite side of the transversal there. So it would be those 2 angles. I could switch the sides, and instead of it being on the left and the right, then I could be the top one on the right and the bottom one on the left. So there are 2 pairs of alternate interior angles. Alternate exterior angles are the exact same idea, but they're going to be on the exterior of the lines. So they're going to be outside the 2 lines. And opposite sides of the transversal again. So 2 lines, transversal. Alternate exterior angles, there's 2 pairs of these also. One would be here and here, or I could do the opposite of that and they would be the same. Then the last pair that we look at are consecutive interior angles, which you'll often hear me refer to as co-interior angles. Some people also call them same-side interior angles, and that's really the point. The co-interior means that they are between the lines, but instead of alternating sides, they're on the same side of the transversal. I'll just abbreviate here for time's sake. So, if I have a line here, a transversal, this one and this one would be co-interior, as would the other pair that's on the other side. Okay? Identifying and being able to name these types of angles is hugely important. So let's do this last example here. There's 2. Example 3, we want to identify all the pairs of the given type of angles. So what I would suggest you do is kind of test yourself right now. Go ahead and put me on pause. Try to answer these A through D on your own, and then come back, because I'm going to go ahead and put the answers on here right now. So the corresponding angles would be angle 1 and angle 5. And that's, again, if you look at, we're looking at this cluster and this cluster. So this is top left, top left. And so then if we were to keep going, that would be angle 2 and angle 6, angle 3 and angle 7, and lastly angle 4 and angle 8. So those are all of our corresponding angles. Alternate interiors, we're going to find along the transversal here in between the lines, and they're going to zigzag back and forth. So it would be angle 2 and angle 7, and then it would be angle 4 and angle 5. Alternate exterior, we'll be looking on the outside of the lines, so it would be angle 1 and angle 8, and then angle 3 and angle 6. And then lastly, the co-interiors would be between and on the same side, so that would be angle 2 and angle 5, and then it would be angle 4 and angle 7. So then the last example just wants us to name them. Instead of picking them out, it wants us to look at where they are. So for example A, I noticed that 1 and 5 occupy the exact same position. I can kind of eliminate some of the other ones because 1 is on the inside of the lines and 1 is on the outside of the lines. So that actually eliminates all of the other 3. So these are going to be corresponding. And again, if you want to try these yourself, go ahead and put this on pause and then come back and check your answers. For example B, here's the transversal. 2 and 7 are both outside of the lines and they alternate sides. So these are going to be alternate exterior angles. And 5 and 4 do the same thing but on the inside. So these are alternate interior angles. So that's pretty much it. This section is all about vocabulary and labeling and being able to identify the points. So if you've got all of your notes copied down, then you can go ahead and begin the assignment.